Now in this video, we are going to discuss dot product or scalar product of two vectors. Dot product or scalar product of two vectors A and B is defined as vector A dot vector B is equal to magnitude of vector A into magnitude of vector B into cos theta, where theta is the angle between vectors A and B. So this product is called dot product because it is denoted by A dot B, and this product is called scalar product because the result of this kind of product is always scalar. Now we may infer some very important corollaries based on the definition of a scalar product. Let us write the product once again. So, corollary number 1. If vector A is parallel to vector B, then angle between them, that is theta, is equal to 0, because if two vectors are parallel to each other, the angle between them is taken as 0. So if theta is equal to 0, cos theta is equal to 1, because cos 0 is 1. So putting cos theta is equal to 1 in this definition, we have A vector dot B vector is equal to magnitude of vector A into magnitude of vector B. Now since every vector is parallel to itself, say A vector is parallel to A vector and B vector is parallel to B vector, we may write it as A vector dot A vector is equal to magnitude of A into magnitude of A, which may also be written as magnitude of vector A square. Similarly, B vector dot B vector is equal to magnitude of B vector square, and C vector dot C vector is equal to magnitude of C vector square, and so on. Now corollary 2, if vector A is perpendicular to vector B, then theta is equal to 90 degree and cos theta is equal to 0 because cos 90 is 0. So if we substitute cos theta is equal to 0 in this result, we get vector A dot vector B is equal to 0. That means if two vectors are perpendicular to each other, their dot product is always 0. Corollary 3, since I cap is parallel to I cap and magnitude of I cap is 1, as we know that I cap is a unit vector, so its magnitude is 1. So I cap dot I cap must be equal to magnitude of I cap square, and magnitude of I cap is 1, so 1 square, that is 1. Similarly, J cap dot J cap is equal to 1 and K cap dot K cap is also equal to 1. So we may summarize this result as I dot I cap J cap dot J cap is equal to K cap dot K cap is equal to 1. Now corollary 4, since I cap is perpendicular to J cap and K cap, and similarly cap and k cap, or we may say that k cap is perpendicular to I cap and j cap. So I cap dot j cap is equal to 0. Similarly, j cap dot k cap is equal to 0, and k cap dot I cap is also equal to 0. So since dot product of two perpendicular vectors is always equal to 0, so I cap dot j cap is equal to 0 because I cap and j cap both are perpendicular to each other. Similarly, j cap dot k cap is equal to 0 because these two are also perpendicular to each other, and in the same way k cap dot I cap is also equal to 0. And since dot product is commutative, we may write these results as j dot j cap dot I cap is also equal to 0, or k cap dot j cap is equal to 0, and I cap dot k cap is equal to 0.